Yeah. Can you able to see my screen, right? Hello.
Yes, sir. I can see.
So now tell me what is the expression for this? A bar B C bar, right?
Hmm.
And plus next A B C. So this is the expression we got, and I'm just not solving. I'm not solving. You see the full adder expression. So it is the same as that. Okay.
Hmm.
So I'm just simply writing and it's equals to A XOR B dot C. So by solving this expression, we'll get okay, A XOR B XOR C XOR. Okay. Sorry. Now it's perfect. So we got the expression for differences A XOR B XOR C XOR. Now come to borrow. K map for borrow. Okay. So three variables. So consider three variables. It means let's see. A B C. So and A dash A dot C dot C B C and B C bar. And we know that the value of 0, 1, 3, 2, only 4, 5, 7, 6. So this is the K map for the borrow. So where there is a 1, we need to keep 1, right? So come to borrow. Yeah. We have 181. Again 182, 183, and 187. So just come here and keep.
1, 2, 3, 7. Yes, sir.
Yes, 1, 2.
3, 2, 7.
So is there any possible to pair up?
Where is sir?
Yeah. One pair. That
4.
is 1. Yes, perfect.
Ah, 3, 3
And
possible.
P2
3.
and again 3 comma 7. So these are the possible
Yes.
pairs that we have. Now just do one by one. Row and column for I'm just doing 1 comma 3, right? I'm doing pair 1 comma 3. Okay. row and column. Just consider. So how many rows we have for 1 comma 3? Only one, that is A bar. And column we have two columns, B bar C, B bar C and BC. Now you know that B bar plus B equals to 1. Similarly C plus C equals
C
to
C
2. So what will be
C
the output?
A bar C.
A bar C. Okay, this is one. Now come to another pair.
Wow. 3 comma 2.
3 comma 2. Okay, pair 3 comma 2. Okay,
A bar
row.
A B.
Yeah. So you just tell me the answer. No need to be like
Yes sir. A bar B.
let me do. It will be remember for when you see. Now two 3 comma right. So A bar and column as BC and B bars
Hmm.
BC bar. So
B
after
bar.
getting we'll get
A B.
what we'll
A
get?
bar B. A bar. A bar B.
Yes. A bar B is now what we have next pair
3 comma 7.
3
Rows
comma
2.
7 right perfect. So row and
Bar A B C.
yeah, perfect. So what we have two rows right.
Yes sir.
So A bar A get cancelled. A bar and A get cancelled and what remains BC column only one column and two rows right.
Yes sir.
So BC is output. Now combine all.
A bar C plus A bar
R equals to
B C bar.
so it here so R equals to no. First we have A bar C plus A bar B plus BC. Am I right? So this is the expression we got, and here this is the expression, right? So based on this expression, we need to derive a circuit, design a circuit. Now, some how many inputs we have? A, B, and C, and we require a XOR gate which takes three inputs, right? Now you tell me how many gates we require for this gate. Just look at the expressions and tell me how many gates do we require. This is one gate, and similarly, how many gates we require for borrow? You see the expression A bar C plus A bar B plus BC. So three AND gates.
And again.
Yeah. I'm designing three AND gates. Okay. Now come here. So I'll just add Let's focus how I'm doing. Simple. It's very simple, right? Digital electronics is very simple. What do you say?
Yes, sir.
Are you getting it right? Just fun it, yeah. Learn through fun. These are, and C's are. These are the inputs. So difference. Dot different equals to A, A, dot B, C. Okay. So that is a difference for that is a difference. Now we need a borrow. Okay. A bar, C bar, C. So three. So consider how many and not gates we require. Do we require not gates?
Yes, sir. Yes, sir. Uh,
Considering one not
for
gate. How many not gates we require?
for a bar and
So this is one. A bar C. Okay. I'm connecting this one. A bar and C for the first expression. And next expression is A bar B. Okay. Simply I'll take another NOT gate. So this is A bar. It's very easy, right?
yes, sir.
When you understand the number system, the truth tables and basic gates, then only the digital electronics will become very, very easy. And last one is B and C. After that, what we need to do? Yeah, we need one OR gate. Okay,
Yes, sir.
it's very simple, bro. Very, very simple. Just connect this. One, two, just like this. Four. Bar equals to A bar C plus A bar B plus B C. So this is the working principles of both the gates, and these are very important. You got it right?
Yes, sir. Three inputs and two outputs.
Yes, perfect. Three inputs and four inputs. Similarly, you can design also that four inputs and two outputs, but it becomes very complicated. So we require two
Yes,
power four combination of inputs from 00 to
yes,
4 4 ones. Okay.
16.
Yeah, 16.
Yes. Mm.
You understand, right? What is off subtractor and full subtractor, how we design gate, how to design KMA for difference and borrow. Okay. So what is application of this? So we create a circuit for off adder and off adder, full adder, off subtractor and full subtractor. So while designing a computer or any electronic devices to add certain number, we use these gates, right? You got
Yes.
the applications. If you want to add something in a digital electronics, so in the backend process, we create a hardware which will have a full adder, half adder, full subtractor, and half subtractor. Okay, this is the basics application for these gates. Okay, tomorrow we'll discuss multiplexer and demultiplexer. Okay,
Mm.
the tomorrow is very important. Okay,
Okay, sir. Okay.
okay,
So
I'll
once
share.
you say this,
Uh, Tell
your
me.
K map for difference.
Difference for
Here, a
which one? For second one or third one? Like sorry, for
second,
three gate like three inputs for two inputs.
three inputs.
K
Difference.
map for difference, right?
Mm. Answer once you take this. A bar,
Yeah.
B bar, C.
See, if, just multiply it. We don't have any pairings, any chords and
This,
any octals. So you just
this
multiply
side.
it. Yeah, yeah. Yeah, you get it right. So let me show you it. This we have right.
Mm.
Um, you see this. You just open the book previous class. That is day 5 notes where we discuss. Are you getting me right?
Okay, sir. Okay, I'll check it once.
Okay, check it. Is it same as it is same? After
Yes, sir.
simplifying the expression, we'll get A, XOR, B, XOR, C.
Okay, sir.
So, so to for time being, just something, just I just wrote directly. Okay, just see it.
Once I will see, sir.
Sorry.
Once I will see, sir. I'll check it.
Okay, it is the same as full adder. Okay,
Yes, sir. Okay, sir.
okay. I'll send the notes. Don't worry. Okay, I'm
Okay, sir.
ending class here.
Okay,
Any
sir.
doubt?
No, sir. No, sir.
Okay. Good night. We'll meet tomorrow.
Okay, sir.
Yeah,
Fine, sir.
bye. Bye.
Bye, sir.